Good afternoon. Today's topic will be your week 003, electric flux density, Gauss Law, and divergence. We will explain this principle. Okay, for this subject, ECE 6201, Electromagnetics 1. I'm your OLC from Engineering Department from Makati. Good afternoon. Okay, let's start. Okay, let's start with the history of electric flux and Paradise Law. About 1837, the director of the Royal Society in London, Michael Faraday, became very interested in static electric fields and the effect of various insulating materials on these fields. Then this problem had been bothering him during the past 10 years when he was experimenting in his now famous work on induced electromotive force. Okay. Uh, in 1837, according to this history, si Michael Faraday is interesado pa rin siya sa mga sa mga studies about sa static electric field at saka mga epekto nito sa mga various insulating materials. Alam naman natin pag mga insulator or mga conductors or semiconductors is depende sa materials kung conductor ba siya or nagko-conduct ng electric or nag-a-allowed ng flow ng electric. Kung insulator naman is nagre-resist ng electric current. Katulad dito sa materials na to, ang study niya is about sa static electric field and effect of various insulating materials on this field. Okay? With this principle of electromagnet, we know that the input for the electromagnet is the electric, then the output will be the magnetism. Okay, through this study of Michael Faraday, this problem have been bothering him during the past 10 years when he was experimenting in his now famous work on induced electromotive force. Okay, sa induced electromotive force, kung ang principle is generator is ang magiging output natin is current, then ang magiging input is yung mechanical energy. Katulad din sa induced electromotive force is nai-induce or nagkakameron ng voltage or nagkaka-produce ng induced electromotive force. Then after nun is magkakameron ng current. Kung ang principle is generator. With that subject completed, and he had a pair of concentric metallic sphere constructed. Then the outer one consisting of two hemispheres that could be firmly clamped together. Then he also prepared shells of insulating materials or dielectric materials or simply a dielectric. Okay, sa kanyang study, doon sa device na yun, sa experiment na materials na yun, is ang outer one niya is nagko-consist ng dalawang hemispheres that could be firmly clamped together. Then he also prepared shells of insulating materials or meron siyang dielectric materials. Okay? Kaya mapapansin natin dati sa mga formula natin, sa mga Coulomb's law is meron tayong dielectric materials or yung dielectric constant na permittivity or simply dielectric that will occupy the entire volume between the concentric spheres. Then we will immediately use his findings about dielectric materials where we are restricting our attention to field in the free space. Okay, that is the study of Michael Faraday about the static electric field and the effect of various insulating materials. Okay. These are the parts of his experiments. His experiments then consisted essentially of the following steps. Okay, ito yung mga steps ng kanyang experiment ni Michael Faraday. First, with the equipment dismantled, the inner sphere was given a known positive charge. Then the hemispheres, when then clamped together around the charged sphere with about 2 cm of dielectric materials between them, then the outer sphere was discharged by connecting it momentarily to ground. Okay, ito yung study niya. Meron siyang yung equipment is naka-dismantle with the inner sphere was given known as positive charge. Meron positive charge. Then the hemispheres were then clamped together there around the charged sphere with about 2 cm of dielectric materials between them. Okay, meron siyang hemisphere na na-clamp together, then around the charged sphere with about 2 cm of dielectric materials between them. Then the third one, steps, the outer sphere was discharged by connecting it momentarily to ground. Okay? Yung outer spheres naman is naging discharge siya by connecting it momentarily to ground. Okay, then the fourth one is the outer space was separated carefully using tools made of insulating materials. Okay, yung outer space nun is naka-separate siya using tools na made of insulating materials in order not to disturb the induced charge on it, and the negative induced charge on each hemisphere was measured. Okay, that is the steps of experiment. Okay, continuation of the experiment of Michael Faraday. Faraday found that the total charge on the outer sphere was equal in magnitude to the original charge placed on the inner sphere, and that this was true regardless of the dielectric materials. Separating the two spheres, then he also concluded that there was some sort of displacement from the inner sphere to the outer, which was independent of the medium. And we now refer to this flux as displacement. And displacement flux or simply electric flux. Okay, paano ba nagkameron ng mga flux or displacement at saka displacement flux or simply electric flux? Okay, nagsimula ito dun sa study ni Faraday. Faraday found the total charge of the outer sphere was equal in magnitude to the original charge placed on the inner sphere, and that this was true regardless of the dielectric material separating the two spheres. Then ito yung kanyang conclusion sa study. He concluded that there was some sort of displacement. After na yung malaman niya na yung total charge on the outer sphere was equal on magnitude to the original charge placed on the inner sphere, and this was true, he concluded that there was some sort of displacement from the inner sphere to the outer sphere, which was independent of the medium. Then he also concluded we now refer to this as flux, as displacement or displacement flux, or simply electric flux. Okay, doon yung nagsimula yung simply yung electric flux doon sa study na yon ng ng kanyang sphere or two sphere, regardless of the electric material separating the two sphere, and about the total charge of the outer sphere was equal into the magnitude of the original charge placed on the inner sphere. Okay. Continuation. Faraday experiments also show, of course, that a large positive charge on the inner sphere induce a correspondingly larger negative charge on the outer sphere, then leading to a direct proportionality between the electric flux and the charge on the inner sphere. The constant of proportionality is dependent on the system of units involved, and we are now fortunate in our use of SI unit or yung international system unit natin. Because the constant is unity, if electric flux is denoted by PC or PC, and the total charge on the inner sphere by Q, then the Faraday experiment and the electric flux PC is measured in the columns. Okay, ito yung naging formula ni Faraday, wherein PC equivalent to total charge of the inner sphere. Okay, PC is yung ating electric flux, or denoted as PC is equals to electric flux. Okay, now by continuation, electric flux density measured in coulombs per square meter, sometimes described as lines per square meter. Okay, alam naman natin, ang electric flux density is na-measure siya gamit ang unit ng coulombs per square meter o yung kanyang area kada metro. Okay, that is coulombs per square meter or coulombs square meter or coulombs meter squared. Sometimes described as line per square meter, for each line is due to one column is given the letter D, which was originally chosen because of the alternate names of displacement flux density or the displacement density. Okay, let's continue. Electric flux density is more descriptive, however, and we will use the term consistently. Okay? Ito na yung term natin ng electric flux. Ang unit niya is line per square meter. Or sa mga ibang libro is tinatawag siya na for each line is due to one column and is given letter D. Okay, that is the unit for electric flux density. Okay, may-measure dito kung gaano kadami ang isang flux kada square meter. Okay, now we will explain the Gauss Law. Okay, what is a Gauss Law? Gauss Law is the total of the electric flux out of a closed surface is equal to the charge enclosed divided by the permittivity. The electric flux through an area is defined as the electric field multiplied by the area of the surface projected in a plane perpendicular to the field. Okay, ang Gauss law kasi ito yung pinaka lahat na o total electric flux out of a closed surface. Ibig sabihin na the total number of electric flux or amount of electric flux in a out of a closed surface equal to the charge enclosed, then divide mo dun sa permittivity. Okay, that the electric flux through an area is defined as, kung ang electric flux naman is within the area, dinidefine natin siya as a electric field multiply natin sa area. Ibig sabihin kung gaano kadami yung amount ng electric field, multiply lang natin sa sakop na area niya of the surface projected in a plane perpendicular to the field. Okay, that is Gauss law. Okay, next. Now we will explain a divergence theorem. What is a divergence theorem? It is a mathematical statement of the physical fact that it is the absence of the creation or destruction of matter, then the density within a region of a space can change only by having it flow into or away from the region through its boundary. Okay, according to this theorem, ito yung ginagamit natin sa mga mathematical statement ng mga physical fact that the absence of the creation or destruction of matter, then equal din to sa density within a region of a space can change only by having it flow into or away from the region through its boundary. Okay, that is divergence theorem.